Okay folks, we're back. What is oxidation number? That's what we're going to talk about today. So often I get asked this question and I do not get the right answer. So let's talk about oxidation number. First of all, like a textbook definition. Okay, a number assigned to an element in a chemical combination which represents the number of electrons lost or gained if the number is negative by an atom of the element in the compound. But I'm going to keep it very simple. I'm just going to talk about single elements for now. It does get more complicated, but that's for another video. So have a look at this table here. The way you calculate oxidation numbers, this is the simplest method. You look at the periodic tables and you look at the groups. So for example, sodium, okay, it's in group 1. So it has a +1 oxidation number. Okay, group 1 +1. Let's look at magnesium. Group 2, 2+ oxidation number. And it's plus because it's lost electrons. The number indicates how many electrons have been lost. So magnesium's lost 2 electrons. Why it loses electrons? To gain stability and have a full inner shell. But that's something we'll talk about later. The central block here, right, from here all the way to here, these are the transition metals and they have variable oxidation states. So that means each element could have a number of different oxidation states depending on the conditions. Again, that's something else. So let's move on. As you can see, group 3 will have +3. An interesting one is carbon. It says +4 or minus. This depends on the conditions. Okay, and that's depending on what it's bonded to. Okay, +4 is generally the standard we go with. Then we're looking at nitrogen, which has a 3-. This means its oxidation 3 is 3- oxidation state, so it's negative. It gains 3 more electrons to get that full octet. And it goes on with oxygen and fluorine. Oxygen is a common one we normally work with, so that's 2-, so it requires 2 more electrons. And look at the halides, the halogens, fluorine, chlorine, bromine, etc. 1-, meaning it's at group 7, it just needs 1 more electron, so it's a -1 charge. So they're the basics. And the noble gases, group 8 is 0 because it's already got a full outer shell. So that's it for now. We're just keeping it simple, and we'll talk about variable oxidation states in another video. Over and out.